Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to you all. In this lesson, I'm going to talk about Raman Spectroscopy, the fingerprint of graphene. Okay, which uh, which I will read the text here, and the diagram related to here is in this here. Again, okay. For those who are interested with this book, you can get my books. You can get the whole content for my book here. Okay, you can search for this book in this website. Okay, so uh, I will read it to you. Okay, the content. So episode 8, Raman Spectroscopy, the fingerprint of graphene. Okay, introduction. The world of graphene. Raman spectroscopy stands as one of the most powerful non-destructive tools for material characterization, often referred to as the fingerprint technique. Raman spectroscopy provides critical insight into structures, defect, electronic behavior, number of layers in graphene materials. With its exceptional sensitivity to atomic vibrations, Raman has become indispensable for researchers aiming to understand and optimize graphene for diverse application. Okay, how it works. Raman spectroscopy involves shining a laser beam onto a sample. Most light scatters elastically, Rayleigh scattering, but small fraction scatters inelastically, shifting in energy due to interaction with phonons, quantified lattice vibrations. Okay, this shifts from a Raman spectrum that reflects vibrational modes of the material. In graphene, three main peaks of interest are G band, approximately 1580 centimeter, represent in plane vibration of sp2 bonded carbon atoms. It is present in all graphitic materials. D band, approximately 1350 cm, rise due to disorder or defects in the lattice is present, indicate structural imperfections or functionalization. 2D band, 2700 cm, a second order overtone of the D band. This peak is sensitive to the number of graphene layers and their stacking order. Key parameters in graphene characterization. Okay, defect density. The intensity ratio between D and G bands provides a direct measure of the degree of disorder in the graphene. High ID per G, uh, equivalent to high defect density. Low ID G equals to pristine or high quality graphene. Number of layers I to D over IG ratio and shape of 2D peak. The 2D changes, the 2D band changes in shape and intensity depending on how many layers are present. Mono layer graphene, sharp and intense 2D peak with I2D over IG over 2, more than 2. Bilayer or multi-layer graphene, broader 2D peak and lower intensity ratios. Strain and doping effects. Peak shift in G and 2D bands, it can indicate stress, strain, and charge doping, helping to assess environmental and processing effects. Practical applications. Okay. Lize et al. 2023 use Raman's spectroscopy to evaluate the functionalization of graphene materials by analyzing D and G peak intensities. This helps quantify how structural defects influence performance in catalysis and electronic system. Wang et al. 2025 applied Raman analysis to confirm the hybridization of graphene with metal oxides in nanocomposites. Changes in Raman spectra validated structural modification and correlated with improved electrochemical behavior. Raman also support high temporal resolution measurements, enabling real-time monitoring of chemical reactions, thermal treatments, or stress condition in graphene layers. Okay, advantages, it is non-destructive, which it can preserve the sample for further testing. It is fast and precise, offers real-time analysis with minimal preparation. High sensitivity, detects even subtle structural differences and defects. And layer estimation, effective in distinguishing between monolayer and few layer graphene. Limitation, surface sensitivity, which limited penetration depth, not ideal for bulk characterization. Substrates influence, signal may be affected by the type of substrates used. Requires calibration. Interpretation of depends on the proper spectral calibration and comparison with reference samples. As a conclusion, Raman spectroscopy is truly the fingerprint of graphene characterization. It provides rich, multidimensional insight into graphene structure, uh, structure, quality, and performance potential, whether it used to confirm its material integrity or guide process optimization. Raman spectroscopy remains a foundational technique in advancement of graphene-based technologies. Okay, okay, okay. That's all. Okay, and that's all for right now. I will. Okay, thank you very much.